Hi everyone. In this video, let's learn about first come first serve scheduling algorithm. FCFS scheduling algorithm is the simplest type of CPU scheduling algorithm. In this method, the process that arrives first in the ready queue gets the CPU first. It is like a queue at an ATM counter. Whoever comes first can be served in the ATM first. After completion of the first person, the next person can be served. FCFS is a non-primitive scheduling algorithm. This means that once a process starts its execution, it runs till its completion. No other process can interrupt or take the CPU even if it has a shorter burst time or arrives later. Let's have an example for FCFS scheduling algorithm. By considering the set of process and their burst time, we can first draw the Gantt chart and then we can compute completion time, turnaround time, waiting time, response time, average turnaround time, average waiting time, and average response time. In our example, we have three processes, namely P1, P2, and P3 with burst time 5, 3, and 2 units respectively. Since the arrival time is not given here, it is assumed as all processes arrived at time 0. We know that in first come first serve scheduling algorithm, the process that arrived first gets the CPU first. Since all the processes arrived at same time, we follow the order as P1, P2, then P3. So this is based on the process ID in ascending order. Fine. Now let's draw the Gantt chart first and simultaneously let's calculate the start time and completion time for each process. P1 starts running from 0 to 5 units. That is, it starts from 0, executes from 1, 2, 3, 4 and 5, it gets completed. So now the start time of the process P1 is 0 and the completion time of the process P1 is 5. Next, let's consider the process P2. Its starting time is 5 and its burst time is 3. So it starts execution from 5, then 6, 7 and it completes the execution by 8. Therefore, the starting time is 5 and the completion time is 8 for process P2. Next, process P3. Its starting time is 8 and burst time is 2. Now, it starts execution from 8, then 9 and it completes the execution by 10. Therefore, the start time is 8 for process P3 and completion time is 10 for process P3. Now let's calculate the turnaround time. It is calculated as completion time minus arrival time. Here in our problem, all the process arrived at time 0. So for process P1, it is 5 minus 0. That is, the completion time is 5 and the arrival time is 0. So 5 minus 0 is equal to 5. Next, for process P2, it is 8 minus 0 is equal to 8. Next, for process P3, it is 10 minus 0 is equal to 10. Next, we can calculate the waiting time. It is calculated as turnaround time minus burst time. So for process P1, the turnaround time is 5 and the burst time is 5. So 5 minus 5 is equal to 0. 0 is the waiting time for process P1. Next, for process P2, the turnaround time is 8 and burst time is 3. The waiting time is 8 minus 3 is equal to 5 for process P2. Next, for process P3, the turnaround time is 10 and burst time is 2. So 10 minus 2 is equal to 8. 8 is the waiting time for process P3. Next, we can calculate the response time. It is calculated by start time minus arrival time. We know that the arrival time for all the process in our problem is 0. So for process P1, the start time and arrival time is 0. Therefore, 0 minus 0 is equal to 0. Next, for process P2, the start time is 5 and arrival time is 0. So, 5 minus 0 is equal to 5. Next, for the process P3, the start time is 8 and arrival time is 0. Therefore, 8 minus 0 is equal to 8. So, the response time for process P1 is 0, for process P2 is 5 and for process P3 it is 8. Next, we can calculate the average turnaround time. using the formula sum of all turnaround times divided by number of process. In our problem, we have three processes, namely P1, P2, P3. The sum of all turnaround time value was taken from the above table. So for P1, the turnaround time is 5, and for process P2 the turnaround time is 8, and for process P3 the turnaround time is 10. So by substituting it in the formula, we get 5 plus 8 plus 10 divided by 3 is equivalent to 23 divided by 3, and finally we get the value for average turnaround time is 7.7. Next, we can calculate average waiting time using the formula sum of all waiting times divided by number of process. So the waiting time for process P1 in this table is 0, for P2 is 5, and for P3 it is 8. So by substituting it in the formula, we get 0 plus 5 plus 8 divided by 3, and the value is 4.3. Finally, we can calculate the average response time using the formula sum of all response time divided by number of process. So the response time for process P1 is 0, for process P2 is 5, and for process P3 is 8. So by substituting the formula, we get 0 plus 5 plus 8 divided by 3, which is equivalent to 4.3. So hope you are clear in FCFS scheduling algorithm with this example problem. Advantages of FCFS scheduling algorithms are: it is simple and easy to understand, it is easy to implement, there is no starvation since every process gets its own turn. The disadvantages are: shortest process wait behind the long process and experiences a long delays, which leads to Convey effect. It favors CPU bound processes over IO bound processes and results in low CPU and device utilization. The overall performance is poor due to high average waiting time. Let's consider the set of following processes with their arrival time and burst time. Using first come first serve scheduling algorithm, first we can draw the Gantt chart, then we can compute completion time, turnaround time, waiting time, response time, average turnaround time, average waiting time, and average response time. Yes, in our problem, we have three processes, namely P1, P2, and P3, with arrival time 0 to 9 and burst time 6 to 1 units respectively. We know that in first come first serve scheduling algorithm, the process that arrives first gets the CPU and runs completely. Since process P1 arrives at time 0, then process P2 arrives at time 2 and process P3 arrives at time 9. So based on the arrival time, the execution order of the processes is P1, P2 and P3. Let's draw the Gantt chart first and simultaneously let's calculate start time and completion time for each process. Fine. For process P1, the start time is 0 and the burst time is 6. So let's start running from 0, then 1, 2, 3, 4, 5, and it completes by 6. Therefore, the start time for the process P1 is 0 and the completion time for the process P1 is 6. Next, for process P2, the arrival time is 2 and burst time is 2. Since the process P1 completes by 6, the process P2 has to wait and start running from 6. So, it starts from 6, executes 7 and completes by 8. Therefore, the starting time for process P2 is 6 and the completion time for process P2 is 8. Process P2 completes at time 8. No process arrived at this time slot. So, CPU is ideal from 8 to 9. P3 arrives at the time 9 with burst time 1. So, P3 starts at the time slot 9 and completes by 10. Therefore, the start time of process P3 is 9 and the completion time for process P3 is 10. Next, we can calculate the turnaround time using the formula completion time minus arrival time. For process P1, the completion time is 6 and arrival time is 0. That is, 6 minus 0 is equal to 6. Next, for process P2, the completion time is 8 and the arrival time is 2. That is, 8 minus 2 is equal to 6. For process P3, the completion time is 10 and the arrival time is 9. Therefore, 10 minus 9 is equal to 1. So the turnaround time for process P1 is 6, for process P2 is 6, and for process P3 is 1. Next, we can calculate the waiting time using the formula turnaround time minus burst time. The turnaround time for process P1 is 6 and burst time for process P1 is 6. So we get 6 minus 6 is equal to 0. For process P2, the turnaround time is 6 and the burst time is 2. So 6 minus 2 is equal to 4. Next, for process P3, the turnaround time is 1 and the burst time is 1. So 1 minus 1 is equal to 0. The waiting time for process P1 is 0, for process P2 is 4, and for process P3 is 0. Next, we can calculate the response time using the formula start time minus arrival time. For process P1, the start time is 0 and the arrival time is 0. So by substituting it in the formula, we get 0 minus 0 is equal to 0. For process P2, the start time is 6 and the arrival time is 2. So we get 6 minus 2 is equal to 4. For process P3, the start time is 9 and the arrival time is 9. So we get 9 minus 9 is equal to 0. The response time for process P1 is 0, for process P2 is 4, and for process P3 is 0. Next, we can calculate the average turnaround time using the formula sum of all turnaround times divided by number of processes. So in our problem, we have 3 processes and turnaround times we have calculated earlier for all 3 processes. That is 6 for process P1, 6 for process P2 and 1 for process P3. We can substitute it in the formula and we get 6 plus 6 plus 1 divided by 3, which is equal to 4.3. Next, we can calculate the average waiting time using the formula sum of all waiting times divided by number of processes. We know the waiting time for the process P1, that is 0, for process P2 is 4, and for process P3 is 0. So by substituting in the formula, we get 0 plus 4 plus 0 divided by 3 is equal to 1.3. Finally, we can calculate the average response time using the formula sum of all response times divided by number of processes. The response time for process P1 is 0, for process P2 is 4, and for process P3 is 0. By substituting it in the formula, we get 0 plus 4 plus 0 divided by 3, which is equal to 1.3. So hope you are clear on FCFS scheduling algorithm with arrival time in this example problem. In first come first serve scheduling algorithm, the Conway effect occurs when a longer process occupies a CPU, causing all the shorter process waiting behind it to get delayed. As a result, the waiting time of other processes increases, leading to poor CPU utilization and reduced system efficiency. Let's have a few real-time examples. When a long train crosses, every vehicle behind the closed gate must wait until the train completely passes. Even if some vehicles could move faster, they are all forced to stay until the first one, that is, the train moves completely. So this is called as Conway effect. Similarly, when one customer has many items and everyone else in the line has to wait, even when the people with only a few things to buy. So hope you're clear with this real-time example. Let's have an example when a long task leads Conway effect. When a large truck moves slowly on the road, all the other smaller and faster vehicle behind it also must move slowly until they can overtake. In same way, in FCFS scheduling algorithm, if long process runs first, all the other shorter process must wait. This is called as Conway effect. The next video is when short task leads gives the better CPU utilization. Yes, when small and fast vehicles move first, they quickly clear the road, allowing the large truck behind them to move without delay. Similarly, in CPU scheduling, if shorter processes are given a chance to run first, the waiting time for all the processes reduced and the system becomes faster and more efficient. Now let's have an example by considering the following set of process with their burst time, and we are using first come first serve scheduling algorithm to compute the following: Gantt chart, completion time, turnaround time, waiting time, and average waiting time.
Let's solve this example using the longest process first in the scheduling algorithm. We are using first come first serve algorithm where we have three processes, namely P1, P2, P3 with a burst time of 10, 3 and 1 accordingly. Since all the process arrived at time 0, the scheduler first select the process with the longest burst time. So P1 is executed first. P1 start at time 0. Now let's draw the Gantt chart simultaneously, and it runs continuously for 10 units. That is, it executes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it has been completed its process. So the completion time for process P1 is 10. Next, we are choosing P2, which is having the next largest burst time. So it starts execution from 10 and continues 11, 12 and 13. So its completion time is 13. So the next final process is P3. It has burst time of 1. So it starts from 13 and ends at 14. Now let's calculate the completion time for all the process. For P1, the completion time is 10. For P2, the completion time is 13. And for P3, the completion time is 14. Next, we can calculate the turnaround time using the formula completion time minus arrival time. For process P1, the completion time is 10 and arrival time is 0. Therefore, 10 minus 0 is equal to 10. For process P2, the completion time is 13 and arrival time is 0. Therefore, 13 minus 0 is equal to 13. For process P3, the completion time is 14 and arrival time is 0. Therefore, 14 minus 0 is equal to 14. Next, we can calculate the waiting time using the formula turnaround time minus burst time. For process P1, the turnaround time is 10 and burst time is 10. Therefore, 10 minus 10 is equal to 0. For process P2, the turnaround time is 13 and burst time is 3. Therefore, 13 minus 3 is equal to 10. For process P3, the turnaround time is 14 and burst time is 1. Therefore, 14 minus 1 is equal to 13. Finally, we can calculate the average waiting time using sum of all waiting time divided by number of process. So, if we substitute the values, we get 0 plus 10 plus 13 divided by 3, that is total number of process, which is equivalent to 23 divided by 3. So, we get the value as 7.7 for average waiting time by considering the longest process first in first come first serve scheduling algorithm. Now let's solve this example using the shortest process first in FCFS algorithm. Here we have three processes, namely P1, P2 and P3. P3 is having the burst time 1, P2 is having the burst time 3 and P1 is holding the burst time 10. Since all the process arrive at time 0, the scheduler first selects the process with shortest burst time. So P3 is executed first. It starts at time 0 and runs for 1 unit and ends by 1. So the completion time is 1 for process P3. Next, among the remaining process, P2 has the shortest burst time. So it starts its execution from time 1 and continuously executes for 2, 3 and 4. So it's completing its completion time by 4. Next, P1 gets executed. It starts at time 4 and runs for 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So its completion time is 14. Now let's start calculating the completion time. For process P3, the completion time is 1. For process P2, the completion time is 4. For process P1, the completion time is 14. Next, we can calculate the turnaround time using the formula completion time minus arrival time. So for process P3, it is 1 minus 0. That is, the completion time is 1 and arrival time is 0. Therefore, 1 minus 0 is equal to 1. For process P2, the completion time is 4 and arrival time is 0. That is, 4 minus 0 is equal to 4. For process P1, the completion time is 14 and arrival time is 0. That is, 14 minus 0 is equal to 14. Next, we can calculate the waiting time using the formula turnaround time minus burst time. The turnaround time for process P3 is 1 and burst time is 1. Therefore, 1 minus 1 is equal to 0. Next, for process P2, the turnaround time is 4 and the burst time is 3. Therefore, 4 minus 3 is equal to 1. Next, for process P1, the turnaround time is 14 and burst time is 10. That is, 14 minus 10 is equal to 4. Finally, we can calculate the average waiting time using the formula sum of all waiting time divided by number of process. The waiting time for process P3 is 0, for process P1 is 1, and for process P1 is 4. So 0 plus 1 plus 4 divided by total number of processes is 3. So we get 5 divided by 3, which is equivalent to 1.7. Finally, we can conclude that when the long process executes first and all the shortest process have to wait, resulting the higher average waiting time of 7.7. However, when the shortest process executes first, they finish quickly and reducing the average waiting time to just 1.7. Therefore, the Conway effect occurs when longer process delays the shorter process, leading to poor CPU utilization and increases the waiting time. So hope you are clear in Conway effect with this example.
Thank you all.